All right, algebra. So today is just a review with the recursive formula and the sequence formula. Remember, we're skipping anything that has multiplication attached in the recursive formula. And if you get a list of sequence numbers, like on part 2 of today's notes, you'll skip anything that isn't subtraction or addition. So let's look. We're doing notes for sequence and recursive formulas. All right. So part 1 says find the first 5 terms of each sequence. We're going to skip number 1 because it says number 1. Skip because it says 3 times a sub n minus 1. It says 3 times, so we're going to skip that one. Number 2, we're going to do because it says a sub n minus 1 minus 6. So first it says a sub 1 is 7. And then it says a sub n is equal to a sub n minus 1 minus 6. And this part right here, you can ignore. To be correct mathematically, we have to have that. All that means is this recursive formula is not good for any number prior to the second term. Okay, any term prior to the second term. So it doesn't work for the first term, and here's why. If you plugged in if you wanted to find a sub 1, you'd have to find a sub 0, and there's no such thing as a 0th term in these things. So it only works for terms 2 and up. That's all this means, but you can essentially ignore this, okay? All right, let's do the work and find the stuff. Now, on the previous problems, I showed you how to work out all these problems. If you need any help, please go back to the video that covers the worksheet from yesterday, which is day 2. But I'll go ahead and do number 2 the long way, and then we have to skip 3 and 4 because it says multiplication. So let's just do this on the long way real quick, or at least do the long way for the first 2 things we got to find. We're looking for the first 5 terms. So we're looking for a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Okay, we're given a sub 1, which is 7. So to find a sub 2, we're going to use this formula, which is a sub 2 minus 1, which is a sub 1, right? Minus 6. And we know a sub 1, that's really a sub 1. So a sub 2 is equal to 7 minus 6, which is 1. Yay, so a sub 2 is 1. Now we're going to do the long way again. A sub 3 is equal to a sub 3 minus 1, which is a sub 2 minus 6. So you're going to take a sub 2, which is 1. So a sub 3 is equal to 1 minus 6, which is negative 5. So negative 5. Now we can continue with this stuff. In the calculator, it would just be the first term minus 6 to find the next term, minus 6 to find the next term, minus 6 to find the next term, and then minus 6 to find the next term. Way easier on your calculator, right? So this is our actual answer right here. 7, 1, negative 5, negative 11, and negative 17. We're skipping 3 and 4 because it says, so number 3 we're going to skip because it says 1/2 or negative 1/2 times a sub n minus 1. Can't do it, won't do it. Number 4, we're skipping because it says 1/3. Now, it's not that you can't do these, it's just that Mr. Sherval, our math department, or our math Tomball IC person, had said that we don't have to, or that we can ignore these because usually it takes a lot of one-on-one time. All right, part 2. This is part 1. So part 2. Part 2, number 1, you can tell that this is arithmetic because we take the second term, which is negative 3. minus the first term, which is negative 8, and we find it's 5. Then we take the third term minus the second term and find 5. So we take the fourth term minus the third term and find 5. So our common difference is always 5. We're increasing by 5 every single time, right? So we need to write the nth term formula. We know that a sub 1 is equal to negative 8 by looking at the list, and we know that our d is equal to 5 by doing what we just did. The second term minus the first term, third minus second, fourth minus third. We found that the difference between each of them every single time was 5, so we know we have to do this one. Our nth term, we have to have n in the equation, so a sub n is equal to a sub 1. You remember it was a sub n equals a sub 1 plus n minus 1 times d. So we're going to substitute a sub 1, which is negative 8, plus we have to have n in it for the nth term, n minus 1, times our common difference, which is 5. And that's the equation. We are done. Number two. Let's look at number 2 and see if it's arithmetic or geometric. Well, 81 minus 243 is going to give me negative 162. And then 27 minus 81 is going to give me a different number. So I know that this is not arithmetic. It's probably geometric, which to do that one, we just divide, right? So 81 divided by 243, and we get 1/3, and then 27 divided by 81, and we get 1/3 again. But we don't have to do this one because it's geometric. So we're skipping number 2. But that's how you do it. Skip. Number 3. Do we skip it or do we not skip it? Let's find out. 14 minus negative 3 is going to give me 17. 31 minus 14 gives me 17. And 48 minus 31 gives me 17. We have to do all of them to make sure that it is a common difference. If one of these said 16, 18, any number other than 17, we would stop. It is not a sequence. All right, so we got 17 over and over again. We know that a sub 1 is equal to negative 3 because it says so, and we know that d is equal to positive 17 because we found the common difference, and we know it's positive because it's growing. It went from negative 3 to 14 to 31 to 48. All right, so a sub n is equal to the first term, negative 3, plus, remember we have to have n in the equation for the nth term, and then times the common difference, which is 17. And we're done. That is what we're looking for. We could find any term, the 1,000th term, plug in 1,000 here and 1,000 here, and you're done. The 1,000,000th term, plug in 1,000,000 here and 1,000,000 here, and you're done. All right. Number 4, is it arithmetic or geometric? Well, number 4, we can look at it right away and know it's geometric because it goes from positive to negative. It says 8, then it says negative 20. Then it says positive 50, then it says negative 125. There's no arithmetic sequence that can go positive, negative, so we're going to skip because that is definitely geometric. That's multiplying by a negative number over and over and over again. All right, part 3. We're going to skip number 1 because in the recursive formula, that says 2 times a sub n minus 1. That is geometric, so skip. Number 2, we're looking at, let's see, it says, write the nth term. Number 2 says that a sub 1 is equal to negative 1. And then it has a arithmetic recursive formula. And we know it's arithmetic because there's no multiplication. It's just addition, subtraction. And then it gives you the thing that you can ignore, which is n is greater than or equal to 2. All that is called a qualifier. That's all. So we're going to write the nth term. We know the common difference is this part, and we know that the a sub 1 is this part, and that's all the information we need to write the nth term. So number 2 is going to be a sub n is equal to the first term, negative 1, plus n minus 1 times 3. And we're done. That is it right there. Number 3. We're going to skip it because it says 1/4 times that. So skip because no multiplication for us. And then number 4. Number 4 looks like it might be multiplication, but it's really not. Oops, I missed all that stuff. It's not because there's no multiplication in front of a sub n minus 1. So it says a sub 1 is equal to 1/3. Then it gives you this equation. This is our recursive formula. It's just the name. Minus 4/3. So, and then it gives you the qualifier. N is greater than or equal to 2. Ignore that part. All right. So we can tell that our D is negative 4/3 because that's what's on the back. And then we just plug it into that formula. A sub n is equal to the first term, 1/3, plus n minus 1 times negative 4/3. And we are done. If we want to find the 1,000th term, the 1,000,000th term, whatever term you want, we just plug in that number, whatever term we're looking for. Say a sub, let's call it the 25th term. A sub 25 is equal to blah, 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 25 minus 1 times blah. Right? I hope that explains everything you need. And I will post a key for the worksheet today as well.